Welcome back to another one of my applications of differentiation videos. This will be focusing on optimization, second video. Okay, so the example we're going to use today is going to be, just like in the other video, a farmer, and he's going to have put up a fence on the beach for whatever reason he wants to. Okay, and we're looking for the most area you can get out of the length that he's given us, which is 6 kilometers of fencing. So this is the bigger paddock than in the previous question, in the previous video. And we're going to have y, and we're going to have x. Okay, so we're looking for the most we can get out of 6 kilometers of fencing. So, just like before, we're going to write down the area. Length times width, x times y, and the constraint, which is the perimeter. Perimeter equals, well, we have 2 y's and we have 1x, so x plus 2 y's. We're not going to use the x along here because he's using the ocean. He's using the ocean as a border, so he doesn't have to waste fencing on that area, on that side. Okay, so 6 kilometers is the amount of fencing we're allowed to use, so the perimeter will be equal to 6 kilometers. And that will be equal to x plus 2y. Now x is already on its own, so I'm going to subtract both sides by 2y, which will cancel on here, and we'll be left with 6 minus 2y equals x. Okay, so now we have x on its own, and we can put this into the formula for area. So area is equal to xy. Now it is equal to 6 minus 2y multiplied by y. Keep in mind, these are the same things, because x is equal to 6 minus 2y, therefore we can use either one in that spot. Okay? Should really draw these up showing its right angles. Anyway, so we're going to expand the brackets, and what we're going to get is the area is equal to 6y minus 2y squared. Okay, and just like in the previous video, I explained about maximizing the area and whatnot, and how we go about doing that. And so that means we find the derivative, which will be 6 minus 4y, and then we let it equal to 0, because there's a graph that basically shows y and the area, and how y affects the area. So if we start here, if y is very small, the area is very small, and as we increase y, the area gets larger. Then if we increase it too much, the area gets smaller again. Okay, and we're looking for this point, and at this point, the slope will be 0. So the slope will be 0, the derivative will be 0, therefore the derivative will let the derivative equal 0. So it'll be 0 equals 6 minus 4y. That means 4y equals 6, because I added 4y to both sides. And if we bring that over here, we divide both sides by 4, we get y equals 6 on 4, which equals 1.5 kilometers. Okay, and we have back here x, and that we need y to find it. We now have y, which is 1.5, so we're going to solve it. So x is 6 minus 2y. X equals 6 minus 2y. And we've established that y is equal to 1.5. So if we put this in, x equals 6 minus 2 multiplied by 1.5, that's 3. 6 minus 3, that means x is equal to 3 kilometers. Okay? Okay, so okay, so that means that x is equal to 3 kilometers and y is equal to 1.5 kilometers, And at this, when x is equal to that and y is equal to that, the area is at its largest. So just to sum it up, the area equals x multiplied by y. Area equals 3 multiplied by 1.5, which equals 4.5 kilometers squared. Now, you may be saying, well, that means that this is longer than these sides. X is longer than the y's, and that is the optimum size. If you had it looking like a square and you had it coming up, and that would mean this would be 2, that was 2, and that's 2 because it's 6 kilometers for the perimeter, and you had it as 2, 2, and 2. Well, that wouldn't work because that means the area would be equal to 2 times 2, which would be equal to 4 kilometers squared. So this is 4.5, which means it's bigger. So that's wrong. Even though it's a square, in the other example we did a square, and a square was optimum for that example. In this example, a square is not optimum. We want a rectangle because a rectangle with x being 3 and y being 1.5 is bigger than if it was a square. Okay? Now, I hope that video helped. Thanks for watching and have a good day.